So good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by Synopsys. My name is Cody, and welcome back to Techstrong Learning. We've got an exciting presentation ahead. But before we dive into things, I have just a couple of housekeeping notes I'd like to review with you. First of all, we are recording today's session. So if you miss any of our conversation, if you'd like to rewatch, or if you'd like to share with your team, you will be receiving a recording shortly after we conclude this live session today. Now, if you'd like to contact us, get engaged with our webinar, there are a couple of ways to do so. The first and the easiest option is on the right side of your screen. It is the chat tab. So when you find that chat tab, let us know from where in the world you are joining us. Seeing South Africa, Germany, Virginia, Texas, we've got folks from all over, so let us know. Additionally, if you have any questions, we want you to send those into our Q&A tab, which can be found on the right side of that chat section. Sending in your questions to the Q&A helps us keep track, and we want to be sure to answer your questions today, so be sure to send them in early. Now, if you jump over to the handout section, you'll see there are a couple of additional resources for you today, but I'm actually going to pin to the top one that is of extra importance, so feel free to grab that and check it out while we're progressing through our webinar today. And finally, before we close things out, I will be giving away two $25 Amazon gift cards. So be sure to stick around until the very end to see if you're one of our lucky winners. So our topic today is reporting from the pipeline, the state of software security in DevOps. And joining me today is Steven Zimmerman, Manager of DevOps Security Solutions for Synopsys. So Steven, thank you so much for joining us on Techstrong Learning. Do you want to dive right in for us?
Absolutely, Cody. Thank you. Yeah, good day, everyone. I am Steven Zimmerman, DevOps Security Solutions Manager here at Synopsys. I'm happy to be with this group today, where we're going to explore some intriguing findings from this year's DevSecOps Survey. We've got some rather complex analysis to look through. So if you like data, there's plenty to wet your whistle, plenty here for you to absorb. And if data is not really your thing, don't worry, I will guide us along so that we derive some important information regardless. So yeah, we'll dive right into this then. With this year's report, which considers the responses of contributors in application security, development and engineering, DevOps, and other similar roles, we examined some topics that are relevant to DevSecOps and defining some viable paths toward implementing application security, or AppSec, in a way that is effective, resilient, and scalable as organizations evolve. Taking a sort of expanded view of the 2023 DevSecOps survey, we can see a good number of interesting trends emerging. One of those I have highlighted here in the title, which is that integrated automated AppSec is growing. It's growing in prevalence, in focus, and importance, but organizational pressures are getting in the way of this idea of maybe fully realizing integrated AppSec. Now, we can sort of break this down a little bit more, into some categories to help us derive some more effectual data. First, we've got insight with implications on dev, test, and fix velocity. So that's given weekly or daily releases, accelerating risk detection and time to resolution or time to remediation is a top priority for organizations. And as we'll discuss, we get a general idea that more than half of organizations can make critical fixes within 3 weeks. Now, depending on how frequently you're releasing or what type of applications or data you're dealing with or other security controls you might have in place, this might be fast enough, or it might be dreadfully slow for CI/CD. But either way, we do see indications that organizations are emphasizing secure coding practices and developer security training to minimize delays to this timeline. Now, then we see a defined image of our security tools and of our pipelines. There's a recognition among respondents that integrated and automated security testing is a valuable mechanism to achieve effective DevSecOps. and that we need a way to get clearly prioritized risk information and remediation guidance across all of the participating teams. All of this is intended to be balanced with the speed of our tests, their accuracy, how we triage the results, and how we manage these tools amid running and in growing our business. And then lastly, that it's a team effort. It requires organizational alignment. And this year, we saw that this means cultivating security champions across our pipelines and establishing cross-functional DevSecOps teams. Ultimately, this is driven by a need for greater visibility into risks so that we can generate a clear assessment of risk at every stage across the SDLC, across our pipelines, and keep those pipelines flowing securely. So we've got this idea that security can be at odds with the high velocity development that we've got going on over in engineering. I would caveat that with the idea that they conflict only when not planned nor implemented properly. So this is something that we can actually plan for, since our dev team's priorities are to code new functionality and to improve our applications. And while security isn't necessarily their role, through them performing their role, developers greatly influence security risk. But it's encouraging that organizations are beginning to adopt more frequent security testing. We've got on the left here a data point from this year's survey that shows that 7% of organizations are testing business critical applications daily. And 45% overall are testing multiple times per week. So these first two numbers on the left are indicative of an AppSec approach that's getting us closer to being able to securely and effectively support rapid releases. Of course, we do have 38%, which is rather significant, who are testing business critical applications less than weekly. Now, I think that we all know that our security risk posture is defined by more than just our testing frequency. But if you don't find it, you can't fix it. And depending on your release cadences, these applications are evolving. So our code base is growing. And so we kind of have this moving target on the security risks that exist within our code under management at any given moment. So testing has to keep up because we saw this year that more than 80% of respondents had their delivery schedules impacted by having to fix critical security issues in the software. So we've got this combination of testing and time to remediation that I'll kind of stick on this timeline. First, we're writing our code and we're bringing in our open source dependencies. At some point, a vulnerability is published for that open source, or as is the case with the code that we write, we've got weaknesses or vulnerabilities baked in from the moment that our devs write it. Now, it takes some amount of time for us to discover the security issues. So we can already start to kind of see that we could shrink this timeline down as we perform more frequent testing or maybe with more security capable developers. But, we've got, after we discover this issue, we've got to select new open source components, a new library, or find a patched version, or refactor our code. And then we need to push that security update out. So basically, this is the window of opportunity for an attack. This is what we're trying to shorten or abbreviate with our updated, revamped DevSecOps program. So that's going to involve a few teams to do it properly. As we shift security testing leftward, there's a greater opportunity for us to become more efficient, and that's more efficient with the testing itself, with the remediation, and with shipping code. That leftward shift is key to reducing that risk exposure that we just talked through. And we kind of see this manifest itself in this year's report, with the first data point being 45% of organizations are including developers with AppSec testing, at least to some extent. 36% have established cross-functional DevSecOps teams to kind of oversee and coordinate security testing. And so we can start to derive some impact of this inclusion of more dev and DevOps focused teams by then looking over at our time to remediation. So looking at our chart, we can kind of see some focused responses. The higher numbers, basically, the greater focused responses are denoted as those white sections there. So beginning at the right, where organizations entrust only security teams with AppSec testing, we've got kind of a more even distribution across time to remediation options, but we definitely don't see a concentration toward faster resolution like we begin to see as we add more cross-functional teams, QA teams, and dev teams into the mix with security responsibilities. We can maybe visualize this a little bit more easily from an isometric perspective, with this large peak on the left showing us that 55% of those who include all four teams, so DevSec, QA, and DevSecOps teams, they can patch in 2 to 3 weeks. And looking at our final data point on the left, which is, in the graph obscured slightly, we've got 38% of this all category who can patch in less than 2 weeks. And that's made up of 24% who can patch in 1 to 2, and 14 who can actually patch in less than 1 week, which is by far our highest percentage of single week fixes and our heaviest skew toward a quick remediation. We've got one more interesting data point, I think, from this. And you can kind of see that this upward slope, if you draw your attention toward the bottommost axis, that represents uncertainty of time to remediation. So we see clear evidence of more uncertainty and a lack of visibility into security risk resolution as we shift away from a concerted effort across teams. So from this year's responses, we see that this leftward shift could correlate with accelerated remediation. So let's examine that in terms of the other facet that we discussed earlier, which is testing frequency. Starting with some aggregate insight from our responses, we have an overall figure of 5% of respondent organizations that can resolve critical issues within a week. It's not a large number, but it is a really nice quick target for us to consider fixing these issues in less than a week. And when we look at a slightly longer timeline, we've got 55% who can resolve issues in 1 to 3 weeks. Still, though, the combination of these two is only 60% of our respondents. So we can layer this time to remediation atop our testing frequency, which is what we see here, to derive an interesting trend. We've got our white here again. This trend of more frequent testing as we go up the axis and faster resolution time as we move rightward. So this could confirm what we've been discussing, that there's a correlation between finding it and fixing it. So I will struggle here with the slide change. And let's take an isometric perspective of this. So from this view, we can see more easily some interesting considerations. So over here on the left again, where we have a higher than average percentage of respondents who are testing business critical applications every 2 to 3 months. That is very infrequently. And they're able to address security issues, at least about 29% of them, addressing security issues in 2 to 4 and 4 to 6 months. And so that's an incredibly slow response time to critical issues. Now, could this mean that they have maybe a slower release cadence and they're running tests on these slower release cadences? And so, it could mean that then they're doing those releases and those tests as they roll out security patches. Perhaps we don't want to extrapolate too much. But when we compare that to the notion that we've got 70% of organizations who can make fixes within a week, testing multiple times per week, and 28% of them are testing every day, we can then infer that testing frequency might be a potential enabler or a limiter of our remediation speed. Now, issues that might have been minor fixes, if we'd caught them earlier in development, they can become complete fire drills when we find them after we've deployed our applications or in later stage testing. So if we're going to test more frequently, we're going to need to use a little bit more automated security testing tools and integrate those tools into our IDEs, our code repos, pretty much across our CI pipelines, so that we can identify vulnerabilities and weaknesses in the code as soon as possible before they propagate downstream. So this is going to lean on our integrations and our inclusion of those leftward focused teams that we discussed on the previous slide. These criteria that we see here are greatly impacted by our tech stacks and our DevSecOps maturity. So starting with some aggregate insight from our responses then, we have an overall figure of 5% of respondent organizations. We've got, forgot to progress my slide. So let's introduce maturity into the conversation. In the context of self-assessment of DevSecOps maturity, this includes like a spectrum of things like documented security processes, repeatability of those processes across the organization, a proactive security culture, one that's endorsed by leadership, things like that. So that's what we're talking about when we discuss maturity in this context. So if we're building atop the exploration of testing frequency as a critical part of DevSecOps, do we see this borne out in the maturity data? Well, we've got 34% of respondents who consider themselves sort of a middle tier maturity level, which makes sense, that the middle maturity would kind of skew toward our average response. So looking toward our extremes of level 1, low, or level 5, high maturity, we've got 9% in each of those categories. And so we can see quite nicely from this top-down view that our concentration of those who test multiple times per week, that sits stately here among our higher maturity organizations. And in fact, we've got more than 50% of both of our level 4s and our level 5s who are testing multiple times per week. So, now we have, we do kind of have to recognize we have predictably few low maturity organizations who are testing daily at 2%. But we do see, however, that 14% of our high maturity organizations are testing daily. So if we consider now, there's a lot of data here, if we consider multiple tests per week, we do have 38% of our low maturity organizations testing multiple times a week. Great. But interestingly, we see this quite obvious concentration of those who have really rather infrequent security testing. And that concentration of infrequent security testing is only among our lower maturity organizations. So this may be indicative that an organization that has not yet defined or implemented a DevSecOps program is not maybe suited for frequent testing, or it might be indicative that their release and testing cadences are maybe a little more protracted. Since we do have to consider that DevSecOps isn't only software security, it also includes software development and delivery as well. So let's continue on. Let's take a look and see whether we now have a maturity-influenced time to remediation. When we look at our extremes of maturity again, 16% of our prized level 5s can make critical security patches within 1 week. And that's significantly higher when you compare that to any of our other maturity levels. We've got 7% of our level 4s, 3% of our level 3s, 2% of our level 2s, coincidentally, being able to make critical patches within 1 week. But how do our level 1s do? we've got 0% of our level 1 respondents, level 1 maturity, who can make critical security patches within a week. So that's kind of where we stand. We got 0%. Well, what is the floor then? What's the floor for our level 1s? Well, that's 20% of our level 1s who can patch within 2 weeks, not that 1 week where we see almost a fifth of our level 5s. So we can shift our view a little bit. And although our fastest remediation is kind of obscured by this mountain that we've got here, on this rightmost purple elbow on the right side of the graph there, we have 16% of our level 5s patching within a week. And so that should kind of help orient us a little bit visually on the graph. So this 20% of level 1s who are patching within 2 weeks, that's dwarfed by then the 69% of level 5s that can patch within that same 2-week periods. And that's kind of, the sum almost of that white peak and that purple elbow. And so now we can kind of go back to that extrapolation that we made earlier when we were examining the inclusion of more dev and DevOps roles and how that impacts security risk visibility. We've got 8% of our level 1s and 3% of our level 3s who are unsure of how long it takes to fix things. And so this is a potential indicator that one of our challenges, visibility and transparency, which we'll discuss in a little bit, that might be connected to maturity and a hindrance to remediation speed. So we want to understand that maturity is a spectrum, it's a process. So it may be that some organizations begin their DevSecOps maturation at a point other than visibility and transparency, but we can clearly see the upside of focusing on faster and earlier risk detection on our remediation timescales and of our maturity. So when we consider how this DevSecOps maturity may manifest in our day-to-day business operations, we can see that 55% of low maturity organizations are greatly impacted by having to address a critical security issue. In other words, 55% of our level 1s found security practices to be disruptive when a fix had to be made. And that's not really aligned to DevSecOps. That's when you compare that to a much lower 38% of all of our respondents who were greatly impacted when having to make that fix. And so when we compare that sentiment of fixing critical issues, now the opposite here being it did not have much of an impact on our software delivery schedules. Well, now we're comparing 25% of our level 5s who were not really impacted when having to make a fix, with only 9% of our level 1s who said they weren't impacted. So in essence, we can kind of look to the title in summary, because this topic in particular had a significant amount of data to break down. DevSecOps maturity indicates having the right tools and processes in place to make fixes quickly without disrupting operations and without threatening our shipping deadlines. So we recognize that there may be something to learn by examining a potential distinction among industries. So if we take a top-down view first, looking toward our concentration of white peaks and maybe the skew of the color toward the top of our vertical axis, we can begin to see where the concentrations of higher maturity reside across each industry. So doing this, we see that 22% of our application and software development organizations, they identify at our highest level 5 DevSecOps maturity. That's impressive, right? And then we've got telecommunications and ISPs at 17%. We've got 11% of technology companies citing that they're level 5 maturity. So those are really our three standouts, and they're kind of our less surprising data points, considering that industries that have been focused on software development and application security testing, they should be further along in their DevSecOps maturation process. But the digital transformation is really making every business a software business, whether it's the creation or the ingestion of software for external commercial use, or it's the increased reliance on applications for internal business operations. So industries that might not have historically considered themselves software heavy, they're now confronting this future where DevSecOps is an essential part of their evolution and of their success. Um, consider the notion that each of these industries' constituents are part of some form of a supply chain, right? Some form of supply chain of vendors and of customers, each of whom are becoming increasingly focused on mitigating their application security risk exposure. Nobody wants their security risk posture to be determined by the security inadequacies of another organization. So, we've got 19% of utility companies identifying as level 1 DevSecOps maturity. That is our highest concentration of low maturity, followed closely then by nonprofits at 18%, fintech at 17%, banking and financial, 16% identify as a level 1 maturity. And so we'll take a moment to kind of consider how we define many of those industries I just listed. We've got critical utility infrastructure and financial institutions composing the low end of our maturity spectrum, with potentially highly valuable assets that need to be protected from infiltration or attack. And so, the following point is kind of obscured again from this isometric view, but we have 0% of our government, insurance, nonprofit, retail, and transportation industries, 0% of them identifying with a high DevSecOps maturity. And so these organizations, they've got a long way to go in their DevSecOps evolution. And many of them have a bunch of legacy technology infrastructure and heavy development processes that need to be migrated to a more agile CI/CD or really even DevOps workflows. So establishing security into these highly regulated, maybe notoriously budget conscious, industries, that could be a challenge. But it does need to be done. So, we just alluded to, many industries can't afford to leave themselves exposed, whether they need to ensure consistent uptime, of their infrastructure, of their applications, or they need to safeguard sensitive data, which those applications are accessing or storing or transmitting sensitive data. So accurately assessing your organization's maturity is going to be a crucial part when you're implementing or evolving your DevSecOps initiative. And it's because DevSecOps requisitely involves contributors across roles and across teams. So defining success criteria and establishing a clear path forward, it requires their buy-in and their support. And so one of the most impactful reality checks as you make this justification or this plan for an enhanced DevSecOps program, one of the most impactful reality checks is how long it takes to fix critical issues. Remember, that's the window of opportunity of an attack that we talked about way at the beginning. And so I'll remind you on the left of our first two data points, how quickly almost a fifth of our level 5s or a fifth of our level 1s, how quickly they can make critical fixes. And then we can look rightward and kind of see that color bleeding downward, extending our time to remediation, or perhaps positively extending upward, representing a faster remediation. But we've got less than 10% of insurance, utilities, and nonprofits who can make fixes within 2 weeks. We can combine this, we can sort of combine this chart, with the conclusions that we were making regarding each industry's maturity assessment. Perhaps unsurprisingly, we had application development and technology companies leading in perceived maturity, and they also lead in shortest time to remediation. But interestingly, telecommunications and ISPs, they're in second place for perceived maturity, but they're below average in time to remediation. So there's some dissonance there. There's a discrepancy between how mature they feel and how that actually manifests as a reduction in risk exposure. And then we have government, media, utilities, and education. They're lagging in time to remediation. And fintech, unfortunately, they're leading in the slowest time to remediation, which kind of brings that purple downward alongside education and government. But we can kind of resolve this with their perceived maturity. They could see this coming. If we examine the likelihood that any of these industries could make a critical security fix within 2 weeks, we've only got 6% of utilities and nonprofit organizations who can make fixes within 2 weeks. And we've only got 10% of insurance, 13% of government who can realize a fix within 2 weeks. And now recall that utilities, they were very well aware of their position. They had the highest level 1 maturity response rate with a slight skew toward level 2 amid their respondents. So what does this really mean, right? It's not just a reality check. Depending on your industry, going back to those tech stacks, the processes, the regulations, and so forth, and considering your DevSecOps maturity, we're going to have a few challenges and success criteria that we want to consider. DevSecOps, like I said, is going to require orchestrated tools, processes, standards, all facilitated by those contributing teams from development, DevOps, and security. So the first data point here, we've got 29% of organizations citing cross-functional DevSecOps teams as being key to success. And 33% identify inadequate or poor developer security training as an impediment to DevSecOps. And it's important to understand that the opposite of challenge is not necessarily a success factor, but in the top-down view, it is kind of easiest to see some of our higher concentrations. In the bottom right of your challenges chart, you might be able to see a very small red pixel. In the middle top right by developer security training on our success factors chart, you might see a little white spot. Ultimately, if we're using our highest maturity organizations as sort of our guiding stars, the biggest challenges that our level 5s identify are changing requirements and priorities, that's 40% of them, and insufficient budget, again, another 40%, and that's that tiny dot in red there. So we could interpret this in a few ways, but we've seen in other research that as we establish integrated and automated DevSecOps programs in these higher maturity organizations, changes to priority and budgets can be pain points because the organization's shifting of focus after they've, so to speak, solved the DevSecOps problem. So they tend to move on to other areas of investment and then bring back these budgetary and prioritization pains. And now, interestingly, we see almost a potential opposite impetus for budgetary constraint, which actually leads the challenges among our level 1s. That's on the leftmost side of our left chart, where maybe they're contending to justify an investment in DevSecOps. Now, conversely, our level 5s, they're no longer challenged by training developers on security best practices, nor are they contending anymore with organizational silos. With a mature DevSecOps program, complete with all that integrated and automated application security testing, we break down those silos, we close those feedback loops, whereas our level 1s, they're still confronting those areas. When we shift our perspective again, we can see an interesting trend that, what each maturity level considers to be its key success factors. We can see that 40% of our level 5s emphasize the influence of developer security training and having security champions within development and DevOps. They show that, that they consider these success factors. This might reflect that they've overcome these challenges in earlier stages, like we saw on the left. Now, we can interpret the success factors of stage 1 as maybe potentially the most common starting points among our respondents. They're trying to overcome that challenge of organizational silos by establishing security champions and open communication across teams. As our respondents progress in maturity, then they begin to layer on developer security training and integrated security testing so that they detect and fix issues faster, so that they can establish security gates, and then ultimately, preclude issues as code is being written. Ultimately, they formalize this kind of at this level 5 maturity with established teams to oversee their DevSecOps program as it evolves. The net result of sort of these phased successes is this final data point on the bottom left. We have about twice as many organizations who can make critical fixes within a week after they've integrated security testing and established those cross-functional teams and more open communications and security visibility. So overall, we see a skew toward faster remediation when there's cross-team communication, developer security training, and integrated testing. So where do we go from here? How do we use this knowledge, and the conclusions that we just made based on this data? We're intent on establishing a DevSecOps program that puts us in a position to grow and evolve as an organization while minimizing our software security risk exposure. But here's the problem. The way that a lot of teams have been doing it so far, particularly those lower maturity ones, is effectively bolting it onto their DevOps pipelines. They're taking these legacy security products, they're using APIs to kind of drive them from their CI pipelines. So we end up with this completely separate set of security functions that on paper should give us all we need for DevSecOps, but they lack a connective tissue, so to speak, which we really only get with deliberate DevSecOps. This approach makes a lot of issues. Some tests are manual, others are automated. So how do we scale that with the efficiency that we talked about? They don't have a cohesive implementation, so they're prone to breaking workflows and slowing down those build and release pipelines. And they generate an inordinate amount of results, and which are often maybe contradictory or unclear. And so we end up with a DevSecOps initiative it's just not really aligned from within. And that is a huge problem for developers because they've got their own sort of mini workflows that exist in this superposition state that's kind of within that DevOps infinity loop and kind of tangential to that DevOps infinity loop that we're all familiar with. Developers have too many of their own development tools that they have to run and manage, let alone anything else as prescribed by security, which might create additional friction. They're trying to balance code quality with development speed, and they're trying not to introduce new issues into their projects. And one dev team's tech stack is probably not going to match another dev team's tech stack. So trying to create sort of a one-size-fits-all security pipeline is really just untenable. So with no continuous normalized feedback, different priorities, obscure remediation requirements, things like that, it's going to cause confusion among devs, and it's going to make scaling secure development a challenge. But we already saw developer security enablement defined as a success factor, right? We know that a concerted approach to security includes developers in a way that moves forward with AppSec. but not all developers share the same experience or the same knowledge regarding application security or secure coding practices. So I guess we've got all this new development, which means an increase in staffing for developers commonly. With 82%, our first data point here, 82% of managers are emphasizing secure coding education when they're staffing their teams. Now, developers could be weak links for security. Again, I might caveat this if they're not enabled or trained properly for security. So our DevSecOps programs need to account for this by helping developers to write more secure code. 88% of developers know this, but only 14% of them view AppSec as a priority when they write code. And we need a way, though, to educate developers and foster application security awareness and also application security capabilities among developers. And it needs to be done as part of their workflows so that we accelerate remediation of the stuff that we do ultimately find during our security testing. And we know that 76% of developers believe that security training would actually help their productivity. And why is that? It's because there's all of this rework that comes from failed security tests, especially when those tests happen downstream. And when that occurs, our developer workflows just go straight out the window. And so embedding developer security training into DevSecOps programs means that we're not diverting resources from new development, we're eliminating the backlog of vulnerabilities. So we end up becoming more secure, more efficient, and ultimately we're generating a greater ROI on our security program, which is great. We can turn security from a cost center into a business driver, essentially. We become more trusted among our customers and our partners who are part of that supply chain I mentioned earlier, and they're seeking attestation of security, and we start to accelerate security and development in unison. So that's why we have to elevate the conversation where DevSecOps isn't just about plugging tools into your CI pipeline. It's about taking a moment to plan our steps, to plan our next steps, with an eye on how to make this better than we've done in the past. And if we're already eyeing new security tools, then it's the processes that are also going to need to change with them. So really, our version 2.0, so to speak, of our DevSecOps program is going to focus on maximizing velocity and preparing to scale security as our businesses and our projects grow. We'll do that with more smaller, more purpose-built tests that we run deliberately and intelligently at the right time in our pipeline, using situational and contextual awareness that we get from integration into that pipeline. And we'll incorporate those success criteria, some of which we talked about. And that success criteria should be defined by the various contributing teams and those cross-functional roles and cross-functional teams so that we ultimately prioritize the appropriate risks. So we'll regard this as our concerted playbook. And I'll break this down into something that we can sort of procedurally walk through. First off, we have this panoply of application security testing tools that we can integrate into our pipelines. We've got scanning activities like SAST, static analysis, SCA being software composition analysis. I'm looking for known issues in open source software. We do have things like threat modeling and manual code review and pen testing that are more manual. But our ability to get all this done in the smoothest way possible is really just limited by how much security, development, and DevOps teams, how much they are sidelined by complexity, by performance issues, and by those distracting, noisy results. So let's focus on 4 main areas. The first of which being efficiency and velocity, meaning we run just enough tests to meet security and risk needs without slowing things down. This includes integration and automation, those mechanisms to help us shift security left, to fix issues faster, and to lower that cost and time to remediation. That will help foster the priority and efficacy. That's performing our tests quickly when they do need to be run, closing those feedback loops from dev to security and then back to dev again with the shortest lead time possible. And we need to focus on efficacy as well and eliminate the risks that matter to the project and to the business. So that means prioritization, that means triage, and we need to make sure that we use context in each of those, application or environmental context. Now with security enablement, this means establishing security standards and fostering security risk awareness and risk management best practices across the pipeline and across those cross-functional roles. Developers need insight into the risks, into risks that they might be introducing or insight into risks that we've detected downstream. And they need help understanding how to fix an issue that entered the project inadvertently in the first place. They need all of that as part of their workflows without the additional steps or tools that might adversely affect the first two areas that we see listed here. And then lastly, evolution and scale, which includes, really even requires the use of modular AST tools or an application security platform each of these tests can be then employed on that application or that environmental context. Those code and shipping delays that we talked about earlier, part of that comes from running unnecessary tests or duplicating efforts, in a hard-coded way, so to speak, that doesn't scale. So I'll align this to our SDLC, our pipeline. So let's visualize how this kind of comes together as we start to kind of close this discussion out now. We're doing this somewhat cliche initially. We'll at least do this somewhat cliche, oft-used phrase of shifting security left, so that we're helping developers write more secure code. We're helping them avoid late-stage rework. So that's with SAST and SCA, static analysis, and looking for issues in open source. In the IDE, in our SCM repos, and then we're doing more centralized SAST scanning throughout the pipeline, integrated into our repos and integrated into build. And so this part is often out of the hands of developers who have since moved on to another development branch or another version. So anything detected here and then sent for remediation, that has a greater risk of impeding our dev and DevOps workflows, hence the importance of enabling the developer earlier on before we hit this pipeline scan. We're going to do the same with SCA, finding known vulnerabilities in open source components that our dev teams declare when they write the code. And then we're also getting those transitive dependencies that get resolved when we run the build. With SCA, because we already have our software bill of materials detailing the components and the versions that have been incorporated into our projects, we can continue to monitor for new vulnerabilities that come out any day in the future. And we can instantly trigger alerts and remediation workflows based on policies that we've defined. We're then going to run IAST, that's interactive application security testing. We're going to run IAST alongside the functional tests, the automated Selenium scripts or automated functional tests, what have you, which we're already doing. So we're going to run alongside these pre-production functional tests to observe data access and transmission, insecure configurations of our web applications, any risks that are going to manifest at runtime. So we're going to use this as an additional layer now of risk verification and of prioritization. Because a vulnerability that we detect back here earlier in earlier stages, this may not realize exploitable conditions in runtime. So we might be able to de-escalate that or deprioritize that issue if our organization's risk tolerance policies allow for it. So we're becoming more efficient at each stage as these tests build upon each other. And then we could take a lightweight dynamic analysis solution to kind of support our production environments. That's kind of like a production extension of the value that we get from IAST, or it's almost bordering on that black box automated pen testing in production. And then remember, as I mentioned, we benefit from doing this atop a unified security platform that can scale. One where we can coordinate policies and we can standardize and unify the risk information that we get across this variety of tests. And so all of this should deliver clear and prioritized risk intelligence and remediation guidance into our issue management systems and our issue tracking workflows, so that developers can then take informed, prioritized action on fixing those issues and closing off our DevSecOps loop. We're going to employ two different types of developer security training kind of persistently amid all of this. We're going to focus on enabling our developers to become more risk aware and security capable from the start, so that we prevent the introduction of new risks. And then we're going to provide them training and information that's relevant and associated to the risks that we actually detect, so that we can basically reduce that time to remediation and increase the return on our DevSecOps investment. If I had to pare this down for you, at least for today's conversation, to sort of reach our minimum viable requirement for integrated DevSecOps, that's going to basically be at the developer desktop with like a SAST and SCA plugin, maybe with the same testing integrated into the repo. And we're prepping for our CI pipeline or for our workflows. We have to prepare for those to evolve and for us to scale. So we're going to do that with an AST, an application security testing platform, that enables us to be a little bit more flexible with the tests that we run and how we deploy and how we scale. We'll get some additional risk analysis, like I said, from the pre-production runtime tests that we're already doing. So we'll get extra security insight from our IAST, and then we'll focus on that developer security enablement. So we have kind of covered a significant amount today. A lot of data, and hopefully we've kind of helped derive a bit of a plan moving forward. And yeah, I would be happy, Cody, to take any questions that we might have.
All right, Stephen, thanks so much. For everyone in our audience, go ahead and send in any questions you might have. We've received a couple, so we'll get started with those. So, sorry, one more moment. So you mentioned DevSecOps maturity a lot throughout our program today. Is there a standard way to assess that, or is it something we need to determine for ourselves, that DevSecOps maturity?
Mm-hmm. Yeah, I think so. Maturity could be subjective, certainly, but there are mechanisms. There's ways. There's third parties or resources or whatever that you might be able to use. Synopsys, for example, has a build security and maturity model, a BSIM. That's sort of our standardized metric that that a lot of organizations will use to sort of compare yourselves against your peers. We talked through some industry-based analysis here. We talked through a few different 5-level maturity levels, but ultimately, like I said, DevSecOps, because it requires a concerted effort across teams, and it becomes a little more complicated quite frequently for enterprises with different business units or global organizations with different regional development teams or security clearinghouses and things. It becomes a bit more difficult to remove subjectivity from it. So we do often find that organizations are a bit more successful when they find a standardized metric that has sets of categories and criteria about the technology, about the processes, about roles and responsibilities to perform that assessment internally using working cross-functionally with other teams, so that then you ultimately have kind of a snapshot of your maturity at this point in time, and then you can make a more informed plan and decisions going forward on how to modify your DevSecOps program.
Awesome. Thank you for that, Stephen. Our next question here is, I know that different business units or subsidiaries sometimes have their own security testing processes. How do I help our organization as a whole mature if my team doesn't own that AppSec for everyone?
Yeah. Yes. Thank you. Yeah, it's I think it's difficult. I think many of us in our professional careers, we want to champion for something that helps the organization improve, evolve in a certain way, and it can be tricky with DevSecOps. There's a lot on the line. We're safeguarding sensitive information and sensitive resources, but now, because so many organizations are heavily dependent on software and increased development and shipping speeds, and things like that, we are seeing development and security much more intertwined than they ever have before. And so with that, there's likely other people who recognize the same needs that you have recognized in other teams. And so identifying those people that have the same pain or the same vision that you have for establishing security into DevOps, so to speak, doing that across each of the contributing teams, we tend to find that it's a lot easier to sort of rally the troops and start the conversation rather than it being kind of a one-sided push.
So it's everyone's job to own security at that point.
It is, absolutely.
Awesome. So our next question reads, threats and vulnerabilities are constantly evolving. How do organizations stay ahead of emerging security threats and proactively address vulnerabilities in their software?
I think so. I think it depends on. There's a weakness and a vulnerability first off, and so we've got, for weaknesses, so to speak, we've got standards like the OWASP Top 10 and the CWE categorization, and then we've got vulnerabilities, say in open source, for example, where NIST and where the NIST organization is maintaining a national vulnerability database, but then we've got individual security research firms at security vendors. Synopsys, for example, has a rather large cybersecurity research firm, also compiling proprietary databases of vulnerabilities that haven't been indexed in the NVD yet. And so there's a lot of opportunities and ways, there's a lot of resources available to make sure that you're covering yourself for weaknesses in code that you write, known vulnerabilities in open source components you're using, any vulnerabilities that might not be known by a public organization but may be detected by a research firm. And then you've got, I guess, the things that manifest then at runtime, the exploitable conditions or anomalous activity or malware, unauthorized data access or attempts to gain root access, things like that tend to be more detected when you do your runtime testing, pre-production or deployment or otherwise. And then lastly, you've just got good old pen testing, trying to break through that door. And I think that's kind of the threat landscape we look at now, and things are kind of evolving from there. If you get that coverage, then you're fairly well situated for that evolution in the future.
Well, Stephen, thank you so much for your time today. We are at the top of the hour, so we've got to start to shut things down. But we really appreciate you jumping on here with Techstrong Learning and sharing the vast wealth of knowledge that you have when it comes to DevSecOps. So I think there were a couple of questions we weren't able to get to. We'll make sure to get those forwarded over to you so you can check them out after the fact. But once again, thank you so much for joining us today.
Thank you.
All right, so I would like to remind everyone that we have been recording today's session. You will be receiving an email shortly to access the on-demand link so you can rewatch, maybe you had some questions that didn't go answered, or maybe you wanted something repeated, they will be in that recording and you'll be getting that as soon as possible. You can also find that recording on the Security Boulevard website at securityboulevard.com/webinars. The two winners of our $25 Amazon gift card drawing are Victor L. and Elizabeth V. So to the two of you, keep an eye on your email. You'll be receiving a message from me here shortly to get the gift card over to you. If you don't happen to see that email, check your spam folder just in case it got filtered out. I'd like to thank Synopsys for sponsoring our webinar and for providing these handouts in the handout section. So be sure to grab those before you leave. And to our audience, thank you so much for being here. We really appreciate your questions and your time today. So if you do have the time, just take one extra moment to fill out our post-webinar survey, and we would love to hear your thoughts. Either way, we hope to see you at a future Techstrong learning experience. Have a great rest of your day, and you may disconnect. Thanks again, Stephen.